Hello, my name is Matt Dietz, and this is my screencast regarding my final project. I selected a lesson that involved designing a hot air balloon, and specifically something that I teach currently, the engineering design process. I thought this would be a nice way of conveying that idea of what's involved in the engineering design process through the hot air ballooning. A little overview. The primary goal will be students will explore how one thinks about designing things through the designing of a hot air balloon. Certainly the goal is to get the balloon to fly, but that is probably not going to happen in all cases. And so the assessment was to use this activity as an introduction to the EDP, or the engineering design process. The assessment will be based on the students' record keeping of the activity, the development of a plan, and the ability to defend their plan upon questioning, not their success in getting a balloon to fly. So I'm really looking for the process elements through this. So how exactly does this activity align with STEM practices? First, in regards to asking questions or defining problems, this will primarily be given by the teacher as far as what is the problem, and that it will be as simple as, let's see if we can get a hot air balloon to fly, keeping in mind to document everything the student does. So they will be in a situation where they'll need to ask questions as far as what materials may be available, or what exactly does flight consist of, or what makes a balloon fly as opposed to just sitting stationary or even sinking. So the students will generate the questions and find their own answers to them. Certainly we'll be developing a model, not just a complete model, but in the lesson plan it's suggested that each individual part should be tested as they're building, just to see if they're on the right track. For instance, does the envelope hold air? Does the heat source, or which heat source produces heat more effectively? Next, planning and carrying out investigations. Essentially, unless a student has completed this activity before, everything will be an investigation for them. They may be drawing on prior knowledge, and certainly they will have access to the internet to research what might and might not work. So they will be choosing and carrying out what investigations they deem important. As far as analyzing and interpreting data, this particular activity, and especially the way I'm using it, is somewhat limited as far as what data will be collected. There is some massing of materials. I provide a triple beam balance for them to try and figure out what's light and what is lighter or heavier than each, simply by determining the mass. Again, with using mathematics and computational thinking, they can calculate what articles might make their balloon the lightest. That goes back to the first step in, do they even recognize whether something needs to be light, or are they just looking for what materials they think might be the easiest to construct? Students will then construct their explanations. Everything will be documented, and through that, hopefully the design of their solution will take shape, and this will require going back, changing, reinventing, or redoing prior efforts, seeing what works, what doesn't work, and then certainly within their own group, and then to the class as we culminate with the activity, engage in argument from evidence. What evidence did they find as far as the heat source, which is the most effective heat source? What was the lightest material to build your basket from? and at each step, certainly obtaining information from various sources, evaluating what seems to work best and what doesn't work, which is just as important, and then communicate that information again at the very end. So how does this adhere to the tenets of inquiry? The learner will engage in scientifically oriented questions. The initial question will be teacher provided, but after that the questions will fall upon the student to decide how they want to go about finding the best design that they possibly can, or that will give them the best chance to have a balloon that will work. The learner should certainly give priority to evidence that they experience themselves, or may be obtained from the internet, and they will formulate their explanations on the best way to construct the balloon. Scientific knowledge, this probably could be expanded upon depending on what you wanted to do. For my exercise, it will be somewhat limited, but I do find for the learner to be able to communicate and justify their explanations is a huge part of this activity for me, especially as it relates to the engineering design process and the 5 steps that exist there. With that in mind, let's take a look at the activity. Now, before we get started, I want to warn you that the time that's invested into this activity was much more so than the lesson plan called for. We worked on it for 2 hours. More time would have been great to develop it to where I wanted it to go, and it honestly felt like the activity itself could go at least twice as long as that, to just get a little deeper into some of the concepts. Also, a fire extinguisher is a must-have. You will be dealing with fire. This is what the engineering process looks like, at least what I use. I have seen some more extensive or laid out a little bit differently, and certainly using different terms. Here was the introduction to the assignment. We had 2 rooms that we used. One was more of a research room, the other more a testing and creating room, which worked out very nicely. You can see the supplies in the lower left-hand corner, some of the design ideas in the upper right-hand corner, and students just starting to formulate their plan of attack. The next phase was the construction phase. That included certainly some assembly, but also some testing on different materials as far as whether the heat source or even how some of the materials would work connecting one to the other. That followed up with some initial testing of the earliest balloon designs. The group of girls and the group of young boys to the left both gave it a try, had an idea, went ahead and tried to formulate the plan as best they could, and then went ahead and tested it. Unfortunately, those balloons ended up as charred remains. Neither worked very well. I think by looking at them previously, you could tell that they were maybe doomed to failure. I had a suspicion going into it as they were lighting their heat sources. But what that gave us a chance to do was just back out and take a moment to have some pizza and soda, which is how I had the students come out. And this worked great, because what we did was we took a time to just review where we at. And I have 3 short clips that I'd love for you to watch.
All right, now I think Nephi was on to something.
I am on something right now.
What do you think your current problem is? You burnt 2 balloons up. What do you think your current problem is?
I think that we do not have enough power and hot air to get the motor going.
Okay, so you burnt up 2 balloons, but you think you need more fire. Okay, good, good. Thank you.
Here's Allie.
Allie, will you have a balloon that flies in the next half hour? Why not? What do you think your biggest problem is right now?
We need something that's light and not heavy.
Wait.
And let's hear what Canyon has to say.
All right. Kenyon, apparently, I think we've nailed two things. We said we need a lot of heat, we need things to be light, and what else did you discover?
I think that we need a bigger bag and have more heat in the bag.
More heat in the bag, more volume maybe, huh? All right, good, excellent.
Well, these three went ahead and shared out what their groups were thinking or had experienced and shared that with the other groups. So what we ended up doing was going back and redesigning and improving our projects. The girls went ahead and they started working on a larger envelope and a lighter base. We had some more testing with some heat sources and what could be done. And at this point, we were getting really pinched for time. So my boys requested, can we work together? Because one had a base together, one had a canopy together. And I said, sure, let's go ahead and let's see what kind of success we can have with that.
Are we going to have more fire? That's really what we need here. What? Now, are we heavier than what we were before, do you think? Much heavier. Just leave it go. Honestly, Keenan, when they held theirs, it took a long time for the envelope to swell up, to fill up. No, just hold it. You're going to hold it there for a little while. You have a lot of fire in there. Well, the weight, that doesn't help, but... Vaccine cop. Kevin, but you ought to be around the Ulrichs. They like throwing hot coals at one another. The bag's got, you got flame. I mean, if it, well, that's as much. It will come down. Yeah, it'll come down. Now listen, it's still going to be on fire when it comes down. Try and square it up, yeah, so you can, let's take it outside. Well, yeah, grab the wood part. Let's go outside.
It was really nice to see a group have success. You can see my poor girls in the background. They didn't quite get there. I'm sure they could have after witnessing what the boys ended up with. They just ran out of time. It was a real good experience. I'm anxious to try it with my other classes, and you will hopefully see this sometime soon flying over Midwest High School.